A block X of weight 10 newtons is stacked on a block Y of weight 20 newtons. Block X is fixed to the wall with a light string. The coefficient of static friction between the blocks and between block Y and the ground are both 0.2. What is the value of the minimum force F required to move block Y, and what is the tension T in the string immediately before block Y begins to move? So we'll consider a moment of time when Y just begins to move. And what is our strategy? As usual, we'll write second Newton's law, and it can be written in horizontal components or horizontal projection, or projection on horizontal axis, and in vertical components separately. It can be written for X only, for Y only, or for combined object, which is X two blocks together. And so that we should get some equations to be able to find the required values. So let's consider Y only, and let's consider in horizontal projection or horizontal components of forces only. It means that all vertical forces will have what? Zero horizontal components. And notice that it's usually not useful to consider Y only. Why? Because there will be some force from X on Y. Here it's easy, but in general, especially if there is acceleration, it may be confusing. So let's consider Y and the horizontal components of forces. So what forces are applied on Y? It's F. And notice that tension is applied on X, not Y. Then there is some friction between X and Y tends to move to the left, Y opposes, so friction between X and Y and on Y is to the right. So let it be a frictional 1. Because there is also friction between Y and the ground, so let it be a frictional 2. So it's also to the right because it also opposes motion. And second Newton's law, F is ma, acceleration is 0, and it's quite easy. Just F is balanced by F frictional 1 plus F frictional 2. And now let's consider X only, and also horizontal components of forces, or in projection on horizontal axis. There is tension to the right, and there is friction between X and Y, and applied to X, it will be what? It will be to the left, and it will be of the same magnitude as F frictional 1. Why? Because it's an example of action-reaction pair. All forces arises in pairs, and according to the Newton's third law, this F frictional 1 and this F frictional 1 are action-reaction pair. So F frictional 1 is equal to tension, just balanced. And you can see that you can substitute, and you can see that F is tension plus F frictional 2. And definitely, since coefficients of friction are involved, you remember the definition of frictional force, it's mu times normal reaction. So definitely we should consider vertical components of forces, or second Newton's law in projection on y-axis. And let's consider X only, and in vertical vertical forces are what? 10 newtons, its weight, and normal reaction, its force that Y exerts on X. And F frictional, here it's frictional 1, is equal to what? Mu, 0.2 times normal reaction, and here it's 10 newtons, so F frictional 1 is 2 newtons. And I don't want to consider Y only and vertical components, but here it's easy. There will be just additional force from X on Y, which is equal to this normal reaction, but it more useful and more easier to consider them together, x and y. And if we consider x and y together and in vertical projection only, there will be what? Combined weight, which is 30 newtons, and normal reaction, let it be R, which is what? It's force that the ground exerts on actually y, but or both, it doesn't matter. But now F frictional 2 will be involved, and F frictional 2, it's what? Mu, it's also 0.2 multiplied by normal reaction, but here it's 30. It's quite easy in vertical projection or vertical components. You can see that just R is balanced by 30, so it's 30. So it's what? It's 6 newtons. And we can continue here, and for bores there is F to the left and tension to the right, and here you can see that we get absolutely the same results, that F, it's not required because it's already obtained, but you can see that F is what? In horizontal components it's F frictional 2 plus tension, and you can see that it's the same. So F is F frictional 2, which is 6. Just a moment, you can see that F frictional 1 is 2, so tension is 2 newtons. And F frictional 2 is 6 plus tension, which is 2, so finally it's 8 newtons. So tension is 2 and F is 8, so it's A. And that's all for this question.